What is an algorithm? An algorithm is a very general definition. Is something that receives an input and does something with it, and finally returns an output, and then returns an output. Yeah, so what is this? It receives something and then it performs some kind of stuff, and then finally it tells you the output is going to be this. It's somewhat similar to functions. And algorithm can be very complicated if there are many features, but in this course, this semester, we will learn the simplest algorithms possible. We will learn very simple ones. And so simple that it can be understood by a computer, right? We will make, and so this is why algorithms are very important, especially in these days where computer is very useful. So you know, computer can do many things, but how can you make computer do something for you? You have to write some kind of, you have to make computer understand what you want to do, right? Computer, maybe in the future, maybe if you say something in our natural language to computer may understand that, but not now. For nowadays, computer can understand many things, but still, if you really want to use computer, you have to write some kind of code to make computer understand what you want to do. This is basically things related to that. And there are many programming languages like Python, C, Java, many things like that. They are somehow similar, but they are not quite the same. But they have many things in common. So in this course, we are not going to use a specific programming language. So we will use what we call a pseudocode. Pseudocode. This is not an actual code like Python or Java, like things like that. Not an actual code. Like C or Java or Python, but something similar. So, programming language is basically a language. This is a language to communicate, used to communicate with computer. We use, so for Korean people, we use Korean to communicate. So if you want to tell your friend what you think, then you just tell him or her your just opinion in Korean. That's a language. Programming language is similar. That's why it's called a language, programming language. It's only between us, human, and computer. You want to make, you want to kind of convey your idea to computer. So in order to do that, you need to learn how to use this kind of, how to write code, programming language. By the way, how many of you have some experience with programming language, C, Java, or anything, Python? So can you raise your hand if you have learned some programming language? Okay, I can see, but not all of you. So like I said, if you have some experience, then this can be pretty simple because things will be, you're already familiar with this. But I also had this experience. When I first learned this, I felt it was very difficult. But it's like a language, you know. If you learn a new language, like for instance English, it doesn't make sense at all at the first time, but if you have many practice and listen and write many things, then you will somehow understand very naturally. This is, I think that's the nature of language. So you need practice. So you need to practice how to speak like programming language. It's like speaking English or Korean. So let's see, let me explain you with an example. What's the maximum of 3 numbers? So this is very common or very useful question, especially for computer. What is the maximum? You have a bunch of numbers. Then what is the maximum number among these? This is very simple. There are only 3 numbers. You can immediately see that 41 is the largest. So this is the maximum. But how did you come up with this answer? 41. Everyone knows that answer is 41. How did you get this? You compared with, somehow you just compared everything, right? 41, you compared 25 and then 13 and 41, and then you realize that this is the biggest, so that's the answer. But how can you make computer do this for you? This is very easy, so you don't even need a computer, but just imagine there are like 1 million numbers, and we cannot really do this by looking at them all. In that case, we need a computer to do this for us. But for now, let's write a code to find the maximum number of 3 when 3 numbers are given. So the algorithm is the following. Finding the maximum of 3 numbers. This is the description of the algorithm. Then let me write this. So the input will be 3 numbers, say A, B, and C. So I told you algorithm has an input and then it has an output. What is the output? Is say large. This is the largest number, maximum among 3. This is just a name, large. It can be anything, L or N, M, X, anything. I just named it large to make it easy to remember that it's the maximum. You can say this is maximum. Okay, let me write down. I'm going to write down the pseudocode. I'm going to first write down and then explain. So let's see if you can make sense out of this. So this is the code that compute the maximum number of when 3 numbers are given. Then just to make it easy to explain, let me write down the line numbers. So first line, second line. It's not really necessary, but sometimes it's helpful. So it consists of 8 lines of code. All right, so let's look at each line. Let's look at the algorithm line by line. So what is this? So it means the max 3 is just the name of this algorithm. It can be anything. It's like, it doesn't have to be given like this. Just the name, like your name is something. Your parents gave you that name, but it could have been something else. It's like that. Max 3. Usually, when we name the when we give the name to an algorithm, it's usually some alphabet with some numbers, combination of this. And we have this parenthesis. It means the things inside of the parenthesis will be the input. So we have input ABC. So this means the name of the algorithm is max3, and the input will be 3 numbers, ABC. Okay? And then we have this curly brace. You can see the left curly brace over here and the right curly brace here. This means the things enclosed by this curly brace will be the body of the algorithm. So this means algorithm starts here and ends here. This is the body of the algorithm. So when it receives something, then it will do something that's written in this body. Okay? Right. Now, the second line, let's look at the second. It always goes from the top and goes down one by one line by one line. Large equals A. This means we set this to be this. So large is now A. What is A? The first number of the input. By the way, in mathematics, this is not exactly the same equation that we use in mathematics. You know, what is A equals B? This means they have the same values. So A and B, B and A, there's no distinction between these two, right? They're exactly the same in mathematics, but when we do this pseudocode or programming language, they are different. This means A equals B in programming language. This means we set A will have the same value as B. So B is something already given, and we set A to be the same value as B, right? Like that. So now large becomes A. Okay, A is already given. So if you say, for instance, instead you write A equals large, computer won't understand this. It will say some kind of error message for you. Okay? Anyway, this means large is now A. This now stores A, something like that. Now let's go to the next line. Now we have what's called if statement. If and something, if I write if and some parentheses, it means inside of this parenthesis, it will be some kind of statement that can be either true or false. It's something like a proposition. If this statement is true, it will perform the things inside of this if statement. Otherwise, it doesn't do anything. And by the way, you notice that I indented the next line like this. That means the body of the if statement is from here to here. And this is one statement. It has only one statement inside of the if statement. Okay? If this is true, we will perform this. Otherwise, doesn't do anything. And then go to the next line. So usually, this notation means just kind of a comment. The computer doesn't see this. It's only for us to. It's like taking a note here, which is invisible to computer. So if I write if B, this means we compare large and B, these two numbers. If B is larger than large, then what? If this is large, then we replace large by B, right? Then we set update large. This is our comment. This is one line. So basically the idea is the following. We just assume that the first one is the largest. And then we proceed to the next. And if the second one is larger, then the first one is obviously not the maximum one. So we make now B is the largest one. And then proceed. Now finally compare this with C. Similarly, if C is large, then update large, like this. And then we have checked every number, A, B, and C, and the large will contain really the largest number among A, B, and C after this. And the return large, this means the output will be this. Return something, that means the output will be that thing written after return. That's it, basically. That's the algorithm, what this algorithm is doing. So the idea is, okay, just imagine you have some kind of memory called large. You store the large numbers, maximum number. You are going to store maximum number over here. First, just assume that the first one is the largest one. So large is now 25, right? And then you go to the next line or next number, and then large is 25. Which one is bigger? 25 and 13. 25 is bigger, right? So large is bigger than this, so we don't do anything. This is performed only if this is true. This is not true, so large is still 25 because we don't update large. But now we go to the next line and we compare large with C. Which one's bigger? Large is 25 now. Which is bigger, 25 or C? C is 41, is bigger than 25. So this is true. So this will be performed. This will be executed. So large is now C, which is 41. So large is now 41, and then we go to the next line. The if statement is finished, return large. So you will return 41, which is really the maximum among these three numbers. All right? Does this make sense to you? So this is how algorithm works. You want to write codes like this. And this is not the actual code. So if you write this in your Python or C, then it will return error message because it's not exactly, it does not satisfy the syntax that has to satisfy in your actual code. But there is something similar. There are always like this kind of substitution or if statement, a return statement. If you really want to use computer, you have to really learn that specific language and then just use that, write code according to that language. But basically here, this gives us the idea how algorithm works. Any question about this? And we will see a couple more examples. Okay. Algorithm. Another algorithm. Finding. Now we just consider three numbers, but the number of numbers in our input can be anything. So finding the maximum in a sequence S, S1, S2. So now you have n numbers. We want to find the maximum. How can we do this? So what is the input? Input is basically S. Let's say S and N. So S is a sequence. N is the length of S. Suppose the input is given like this. Then output will be, we want to find the maximum element. Let's say large. Then max. Now I'm going to write down the pseudocode. Right? It should begin with something like this. The name of our algorithm, which I just named max, S and N. S is a sequence, N is a number of elements there. And then now the algorithm begins. By the way, if you want to write down the algorithm, you have to have the idea. if you don't know how to find the maximum yourself, then you cannot really write down the algorithm. First, you have to think about how to find the maximum. There are many different ways, of course, but the simple way, we will try to use the same idea as before. Just say the first one is the large, and then compare with it with the next number. And if the next number is bigger, then update large, and then go to the next number, and then just do the same thing over and over. We have to do this like n times. But n is not given as a specific number like 3 or 4, so we have to use some statement which allows us to repeat something over and over. So first we set large to be S1, the first number in our sequence. Now we will compare this with the second and the third, etc. until n number. So we will use for statement. This is for repetition. So for I from 2 to n. We compare with large with S2, S3 up to n, so we write something like that. If ith number is bigger than large, then we are assuming that large is the largest among the first I-1 numbers, and then compare this with the ith number. If this is Si is bigger, then we have to update this, right? Then large is going to be the new number Si. And then just return large. Okay. Well, this may look a little strange. The indentation is very important in our pseudocode. Indentation tells us when the statement ends and finishes. We could write using this parenthesis or curly brace, but without the curly brace, this means for statement is from here to here. This is for the for statement because they are indented like this. What about this? This is the statement inside if statement because it's indented from here by this. Okay. So usually for something I from A to B, then we write statement 1, statement 2, etc., statement K. This means these statements, if I write like using this indentation, this means they are all part of this for statement. Okay. Or sometimes we can use this, but we can omit this parenthesis if we use indentation this well enough. Because it's clear that it's quite clear from this indentation that this is for the for statement and this is for that. Right? For instance, if I wrote, by the way, what is this? This is not inside for statement because we didn't indent this. So for statement is finished over here. After the for statement is finished, it will return a large. And that will be really the largest among the n numbers. Okay? So why does this work? First, S1, so say S1, S2, let's say S3, S4, n equals 5, for instance. Okay, maybe probably I can just give the precise number, 4, 1, 2, 5, and 3. They don't have to be the same, to be distinct. Let's say this is our sequence. And so S is 4, 1, 2, 5, 2, and n equals 5. That's given. What is the maximum among this? What does this algorithm do is the following. First, large. What is large? It is 4, right? It is 4. And then now we enter the for statement. I is, let's say I. 1, 2, 3, 4, 5. I is here. I starts from 2. So I is 2. We compare SI, which is S2, with large. Which one's bigger? The second one, S2 and 1, 4. 4 is bigger, so we don't update. We don't do this. Now go to the next. After finishing this body of the fourth statement, oh, I didn't explain that. The way this fourth statement works is that for I from A to B, then first do all of this when for I equals A. And then after doing all of this, increase I by 1, and then do the same thing for I. And then repeat this until I becomes B. Once it's done for I equals B, then it's finished. The whole statement is finished. That's how this fourth statement works. Okay? So for instance, I equals 2, we did this, and then go back to the first of the fourth statement, and I is now 3. Compare large with S3. Still large is bigger, so we don't update the value of large. And then increase I by 1, so now I is 4. Compare S4 with large. Which one's bigger, S4 and large? S4 is bigger, so we execute the statement inside this if statement. So large is now what? We replace this by 5. And go back to go to increase I by 1, so now I is 5, and then do the same thing. I is S5 bigger than large. Large is bigger, so we don't do this. We don't perform this statement, so you just skip it. And then now this is I is now n. So fourth statement is finished. So this is done. Now we go to the next line. Return large. So you will return 5 if your input was this. Which is really the maximum of this. Okay? And you can notice that the way this algorithm works is exactly the way we find the maximum among many numbers. There is, of course, a different way. There are many different ways of doing this, but this is, many people can find, I think many people would find the maximum number like this. You just remember, you just look at the first number and then go to the next number, and then just remember the largest one among those that you have seen. And then just remember this, and then just update your largest number. And then if you scan the all numbers at the end, you know the largest number among this. Does this make sense? Any question? Okay, and next. And because we are using pseudocode, we have some freedom to use many things. So this is an algorithm determining whether a given number is prime or not. Okay, again, let me write down and explain. So this is an algorithm. What is an input? Input will be positive integer greater than 1, I would say. Okay. Yeah, maybe I should have written a little earlier. So this is algorithm. Input is n. N is, we assume that n is at least 2 integer, because otherwise not prime. Output is either true or false. True or false. True if n is prime. False if n is not a prime. Okay? And this is the algorithm, the pseudocode. Okay, what is this again? As I told you, this is just the name of our algorithm. This is just underbar, underscore. It's just a letter. It's like an alphabet letter. Is prime, is underscore prime. We do this because we are not allowed to use space in our, usually for programming language. So underscore, this kind of letter is fine. Anyway, this is just a name. It can be anything. Is prime and n is the input. And then you will do this and then it will return something, true or false. So first here, by the way, how do you determine whether a given number is prime or not? A number is a prime if it has a if it does not have any divisor between 2 and n minus 1, right? So we just try to divide every number between 2 and n minus 1. We divide n by every number from 2 to n minus 1. And if this any number of these divides n, it's not going to be n is not going to be a prime, and otherwise it will be a prime number. All right. So let's see. So fourth statement, we are entering the fourth statement. I is from 2 to n minus 1. If now we have an if statement. If I divides n, this is just a pseudocode, so we can write some kind of natural language, sometimes like this. If I divides n, then return false. So return statement here, when we use programming language, whenever return statement is executed, the algorithm just stops there. So here, suppose for instance I equals 2 and then 2 divides n and return false. You don't increase I by 1 and perform this, because the whole algorithm is finished. When it returns something, that's it. It returns something that's done. You don't have to do this. More for bigger I. Okay? Because it always knows the answer. Otherwise, 2 does not divide n, then this is not executed. So I is increased by 1, I is 3, divides n by 3, and then if 3 divides it, return false, otherwise go back. I increase I by 1 and then do this again, etc. until n minus 1. Right? If none of these i's divide n, then this will never be executed. So it will pass the for statement, and then it goes to this. They return true. What does that mean? We checked 2, whether 2 divides n, whether 3 divides n, whether n minus 1 divides n, and then none of these divides n. That means does not have any divisor among this. Then n must be a prime. So it returns true if it passes all of this if statement. Only in that case it returns true. Otherwise, it will just find one divisor and then it returns false and then finish. That's basically the algorithm. What this algorithm says. And basically that's how we determine whether a given number is a prime or not. So for instance, let's see an example. Like n equals, what's a good number? 15, say. What is, okay, let's do this over here. Is prime, so we do this, is prime 15. What does the algorithm do here? So I equals 2. First we say I equals 2 and see if I divides 15. Does I divide 15? 2 does not divide 15. So this is not executed. So it just finishes one this body for I equals 2 case, and then we increase I by 1, so I is now 3, and then do the same thing over here. Does 3 divide 15? Yes. So 3 divides 15, so it returns false. So immediately it returns false. This is it. Now the algorithm is done. And we know that this is true. 15 is not a prime. That is good. On the other hand, suppose is prime, suppose we had like 7. Then first I equals 2. Does 2 divide 7? No. So you just pass this statement. And we increase I by 1. I is 3. Does 3 divide 7? No. So it passed this statement. Increase I by 1. I is 4. 4 does not divide 7, so it passes again. I is 5. 5 does not divide this, so it passes this statement. I equals 6 now. 6 does not divide 7, so it passes this statement. And finally, 6 is n minus 1. It passed the statement for all I from 2 to n minus 1. So it goes to the next line. So it returns true. Okay? So it says that, 7 is a prime. Is this okay? All right. If this seems difficult to you, then I recommend to read textbook and see many codes there and try to write in your own, right? Probably at the first time you will make many mistakes, but that's how you learn new things. Like you learn new language. All right, so let's see one more example. Write an algorithm that finds the second largest element of 3 numbers. So the situation is this. You will be given 3 numbers and you want to find not the largest but the second largest one. So let's name it like max 2, ABC. So what is the input? Input will be a list of 3 numbers, ABC. So ABC will be, let's see, okay. Input will be ABC, 3 numbers. But let's also assume that they're distinct 3 numbers. And output will be second largest. Okay. Now, how can we do this? Because we want to find the second largest, we need to know the largest and the second largest at the same time. So we will use not just one new number like a large, we will keep track of 2 numbers, the largest and the second largest. Okay? Let's say M1 and M2 for this. So first we look at 2 numbers, the first 2 numbers. Either one is bigger or less, right? If A is bigger than B, which one is up to this point? Which one is the largest? A is the largest, right? If A is bigger, so we'll say M1 equals A, and M2 second largest is B. Up to this point, up to the second number, A is the largest and B is the second largest. Okay. Okay, well, it doesn't matter, but just to save space, I'm gonna write over here. M1 equals A, M2 equals B. Else. So this means if else statement, this means if this is true, do this, otherwise do this. Otherwise B is bigger. So M1 must be, the largest must be B, and the second largest must be A up to this point. So this means this, if else statement, if the condition is true, do this statement, and otherwise do the statement after else. Okay. Now what about C? Now we have to look at C. So we have now the M1 is, in any case, this either this is true or not. M1 is the largest among A and B, and M2 will be the largest among A and B. So now we need to compare C with these numbers, M1 and M2. So suppose C is bigger than M1. What does that mean? M1 is the biggest among A and B. And if C is bigger than M1, it will be the biggest among all of these, A, B, C. So C is the biggest one. Then what is the second biggest one then? Okay, so let me write it this way. M2 equals M1, M1 equals C. This means now we update M2 to be M1. We update M1 with C, right? Because C is the biggest one. M1 used to be the biggest one before C, but now it is the second biggest. So M2, we define M2 to be M1, like that. Okay? Is this okay? Otherwise, else, what happens? So C is not the biggest one among three numbers, but now we have to compare C with M2. Else, oh, yeah, let's not use else here, because we have to do one more time. If C is less than M1, but bigger than M2, what does that mean? M1 is still the biggest one, and M2 must be updated, because C is bigger than M2. So now we say M2, we update M2 using C. All right? Oh yeah, so, okay, return, I'm going to write down. Suppose that we have finished it up to this point, and M1 will be the biggest among A, B, C, and M2 will be the second largest among A, B, C. So we want the second largest, so we need to return just M2, and that's the end. So we end. So this is it. In this algorithm, we'll find the second largest of A, B, C. Next. Yes, there are many different ways of doing this. If you can find a better way or a simpler way, go for it. Yes. This is not the only way to do this. Okay? So if I ask you to write down to do algorithm to do something, then all of you there will be many different ways of doing this. This is just one way. Okay? But of course, it will be better if the algorithm, if it is easy to read, if it looks simple, and so you can there is some kind of way to determine whether this algorithm is good or not. We will learn this soon. This is but just one example, right? Yeah, it looks a little complicated. You know, finding the second largest one. This is not a very complicated question, but you know, you see, it looks rather involved. But because computer cannot really understand how we understand things. So we have to, because we have to make this very, very clear. Sometimes, even for simple things, we need to write many lines like this. Any other question? Okay. Okay, now then let me move on to the next section. We have seen very simple algorithm, just finding the maximum, the second maximum, etc. But there can be many, many complicated algorithms, right? Probably one of the most famous or useful algorithm will be sorting algorithm. Example, sort this. Sorting means you write the smallest one at the beginning and the second smallest at the next as the next element, etc. So that the elements are, the numbers are increasing in the increasing order. There are many sorting algorithms. We will learn just one of them. What's called the insertion algorithm. There are many algorithms like insertion sort, bubble sort, quick sort, merge sort. There are many things. We will learn just one of them. By the way, just before I explain the algorithm, just think about how you would sort these numbers. How would you sort these numbers? All right. One student may say something like this: find the maximum or find the smallest one among these, and then place it at the beginning, and then accept that smallest number, and then find the smallest number, and then place it in the second place, etc. That can be another way, one way. But it will be better if it's more efficient. But we will talk about this later. The idea. Let me give you the idea of insertion algorithm. So we sort from the beginning, and then we insert the next number inside of the sequence that have been already sorted, right? So basically, idea of the insertion algorithm is insert Si. So this sequence is S1, S2, Sn. In general, the sequence will be given like this. Insert Si into S1, S2, Si minus 1 already sorted. So idea is S1 sort S1, but that's only one element is already sorted. So insert and then make S1 and S2 in a sorted, etc. And then for ith step, before the I minus 1 numbers before, they have been already sorted. So insert this in the right place, and that gives you the sorted sequence of the first I elements, etc. And then insert the next element into the already sorted numbers, and then do this over and over until you insert the last number. After inserting the last number, we will get the sorted number. All numbers will be sorted. So for instance, like this, we have 13. It is just 13, right? Already, just one thing is already sorted. Now here, from next, consider the next number. 5 and 13. 5 is smaller, so we need to place this before 13. So this becomes 5 13. Basically, this is how we insert 5. So we insert 5 into the previous sequence there. Okay? Now we have 5, 13. Then we need to insert 8, right? Which place do we have to insert 8? Must be between 5 and 13. We insert this over here so that 5, 8, 13, like that. And the next 5, 8, 13, the next number is what? 11. We need to 11 somewhere. Where? How do you find the correct position for 11? First, see if this is bigger than 13. If this is already bigger than 13, it will be the right place. Otherwise, you have to go to the next place, right? This is smaller, 11 is smaller, so compare this with 8. And this is bigger than 8, that means it is the right place for 11 will be between 8 and 13. 5, 8, 11, and 13. And finally, no, not finally, and 20. The next number is 20. And this is already biggest, so we don't have to insert anywhere else. It is just there. So and next, 6. We need to insert 6. Compare 6 with 12. This is smaller than 12, right? So go to the next number. 6 is still smaller than 13. Go to the next. Smaller than 11, smaller than 8, but bigger than 5. So it must be after 5. So finally, we get this. So this is the sorted sequence of the original sequence. All right? This is, we are going to write down a pseudocode that does this kind of step. Okay? But this is the idea. Idea is quite simple. Everyone knows how to do this. But the problem is, can you write down the pseudocode so that computer can understand? So algorithm, insertion, sort. So input, what's the input? S and N. S is a sequence. N is the length. There are n numbers. Output. Output is the same sequence, sorted sequence. It will be S, but it will be sorted. So C, insertion. Let's name this insertion, insert, sort, S and N. Its input will be a sequence and a number, length. All right. Again, I'm gonna just write down and then explain line by line. This can be a little difficult if this is your first time to see this kind of thing. So we need to look at line by line very carefully. Okay, this is it. Looks very complicated, right? So now I'm using this curly brace to indicate that for statement is from here to here, right? For statement begins and it ends. The ending parenthesis will be the same indentation as for the for statement. Okay, so for statement is from here to here, and we have while loop, and this is from here to here. Okay, Then we have while inside for. All right, so what does this mean? This is doing exactly the same thing that we did over here, only in this pseudocode language. So we sort. So here we sort S1, S2, dot, 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 Si minus 1. We sort the first I minus 1 elements, and then we are going to insert Si somewhere there, so that the result will be a sorted sequence of the first I integers, I numbers, right? So how do we do that? Look at this. Compare. If you remember, we compare this with the rightmost number, right? And if this was bigger, if this is bigger than this, then this is the right place. But otherwise, if this is bigger, we have to go to the next one, right? And we have to look at compare this with this. And if this is still bigger, we have to go to the next step, etc. We are going to write down code to do this, okay? So val is the let's write more precisely. So S1, we have S1, S2, S3, dot, 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 Si minus 1, and Si here. And then first we said val, this is val. Because we are going, we want to know the right position for this number. So val, this stores the value of S1. We are going to compare these numbers with val. Okay? And we are going to look at the position. We are going to compare this number with the rightmost number, this, and then the next one, rightmost, and then etc. Right? So first we said we are going to compare val with Sj. We are going to compare this with this. We are going to compare Sj and val. But what is j? We are going to do this from the rightmost one. So j will be I minus 1 at the beginning. Okay? And then compare Sj and this. Okay? So here, while loop, we are entering the while loop. We have this proposition or some kind of statement. We want to know if this statement is true. Also, yeah, this is the first time that we use while loop. So while loop means we repeat the things inside of this while loop until as long as the statement is true. Okay? If the statement is true, it will do this forever. But at some point, this statement will become false, and then while loop will be finished. That's how while loop works. All right. So what does this mean? Sj is big, greater than 1. That means we are comparing some number here, not S0, S minus 1. They are outside of this range, right? So this is obviously must be the case. If val is less than Sj, what does that mean? This is not we cannot place this after this because this is bigger. We have to compare Si with the next number, right? Next number meaning the number to the left of this. What does this? So then what happens? So suppose, okay. Just maybe it's helpful if you think of this as like, okay. I'm not sure if I can write this down. Think of this as number inside of boxes like this. Maybe it's helpful. Something like that. Suppose Sj is somewhere here. Sj, so Sj plus 1, and then etc. Right, like that. Okay. So we compare val with Sj here. What happens if val is smaller than Sj? So basically we want to place this number into some of these boxes, right? But if this is bigger, the number that's written here is bigger, that means we have to go further to the left, right? Because this is smaller. So in this case, what does this mean? This means the number written over here, somewhere here, this will be now going to the next what's this? Next box. Okay? Move this number to the next, and then decrease j by 1. J equals j minus 1 means update j by j minus 1. All right? Okay, the situation is the following. Initially, this will be empty. So basically, the situation is like this. Okay, maybe I can write a little longer. At this stage, so suppose this is Sj plus 1, etc. Basically, we will have numbers inside these boxes like this. The situation is like this one is empty. So we are going to see if this is the right place for val. If this is val is bigger than this, then this is the right place. But otherwise, if Sj is bigger, this is not the correct place for val. That means we are going to move this to the next slot, and then so this just jumps from here to here, and then now j is now over here, and then compare val and see if this is the right place for val, etc. Okay? Yeah, I'm explaining many things, but idea is very simple. Okay? Basically, what the algorithm does is this. See if this is the right place for val by comparing this with this, etc. All right. And then, if this is not true, if this is true, we will just go on all the way to this. But what happens if this is not true? This is not true if this is either j is either smaller than 1 or val is less than Sj. Let's see what happens if that's the case. So Sj is over here. Sj plus 1 is the place is over here. So val is this is not true. That means val is bigger than Sj. That means if you place val over here, it will be bigger than this. And this is always smaller than all of this. So it's the right place. That's the idea. I'm going to explain this using the example that we already saw. So let's do this. Let me explain this algorithm again using the example that we saw. So 5, 8, 11, 13, 12, 20, and 6. At some point, we inserted 6 there, if you remember, right? We inserted 6 at the last stage. Let me explain this using the algorithm. So here, what happens is, okay, let me write using, so this is J. Maybe it's a helpful Sj. No, not Sj. I Sj. Okay, these are the position. So 1, 2, 3, 4, 5. These are the numbers. 5, 8, 11, 13, and 20. We want to insert 6. We want to find the right place for 6. Okay? Okay, maybe 6 here. Oops. We want to insert 6. So val equals 6. Okay? what is j? At the beginning, j will be, so I equals this. J will be the one position earlier than this. J is over here. Okay. Compare, is j bigger, greater than or equal to 1? Yes. J is here. And then compare with val and sj. Which one's bigger? Val and sj. Sj is bigger. What do we do? So Sj is bigger. Sj plus 1. Initially, we assume that this is empty. So Sj plus 1 becomes Sj, right? Here. Oh, where is it? Sj plus 1. This means we move Sj to the next position. So here, it's like 5, 8, 11, 13, and it goes like this. Sj plus 1 is now 20. It was some other numbers, but now it's updated, so it's 20. Now j is now here, right? Because we have to decrease j by 1. Here, if you look at this, j is decreased by 1. And then do the same thing in this while loop. Okay? Compare val with 13. Which one's bigger? Val is big. Sj is bigger, right? Because Sj is bigger, we do this, right? So that means j plus 1, Sj plus 1 now becomes updated by this. So 13 is here. Now j is decreased by 1, j is here. Okay? And then do the same thing in the while loop. Compare j with Sj with val. Which one's bigger, Sj and val? Sj is still bigger. So we have to do the while loop statement inside. So here, 5, 8, and Sj plus 1 now is updated by Sj, so it's over here. Okay, and j is decreased by 1, so j is somewhere is here. Again, look at the statement. Sj, compare Sj and val. Which one's bigger? Sj is still bigger, so we do the while loop again. We perform the statement in the while loop again. So Sj plus 1 here is updated by 8, the Sj, like this. Now, J is here. And then compare Sj and val. Which one's bigger? Val is bigger, right? Sj is 5, val is 6. That means the condition for the while statement is not true anymore, right? This is not true anymore. Val is bigger. That means we don't do anything in this statement. The while loop is now terminated. So this is done. We go to the next line. What is this? Sj plus 1 equals val. J plus 1 is here. This position is now updated by this. Finally updated by this. And this is it. This is how Si is inserted. Okay? And do this for the next I, and then the next I, etc., until I becomes n. And at the end, we get the whole sequence sorted. Any question? Is this difficult? Do you think? But the idea is simple. If you feel like this is difficult, then that's because you're not familiar with this kind of language. But So you need to practice with many examples and things like that. But once you are familiar with this kind of language, then you will understand that this is not that difficult. But anyway, this is one algorithm sorting a sequence, given sequence. So like I said, there are many algorithms doing exactly the same thing. Then which ones but how can you say this one is better than the other, right? Usually, it's better if it takes less time to do this. Sometimes, you know, if there are like 1 million numbers, then we have two algorithms. The one algorithm, if you sort a sequence of million numbers using algorithm 1, say, then suppose that it took like 1 minute. But if you use algorithm 2, it took 3 days. Then obviously, algorithm 1 will be better, right? So one way to determine whether which one's better, then you just use it and then see how much time it needs to do this. If it took less time, then it will be better, right? Because it's faster. We want to do this as quickly as possible. But the problem is, of course, we have to do this if you want to determine. If you want to do this, you have to really compute this. What if it takes many times? And also, it depends on which computer you use. If your computer's performance is better, is like very high performance computer, then it may take less time. And if you use very like a small notebook, then small laptop, then it may take longer. So you cannot really compare by just time. We have to look at the computer as well. So in order to avoid this situation, there is a mathematical way of determining whether some algorithm is better than the other. Okay? By computing how many times a given statement is executed. So for instance, suppose that here, usually for this is the comparison, right? We need to compare this value with other numbers. So you may ask this question: how many times do we need to compare this do we need to have this comparison? For instance, if there are n numbers, n s1 up to sn, how many times do we have to compare two numbers? If the number of times of the comparison is less, then the algorithm will be better. Okay? And we will do this. We will learn how to analyze algorithm by looking at how many times a given statement is executed. And that will be the next topic. Okay? All right, then I will finish here. Thank you for your attention.